By 2040, the U.S. Air Force expects a single $300 million fighter to command 5 autonomous drones, each one cheaper than the missile fired to destroy it. Old air combat is dead. The future is fleets of AI-driven swarms, capable of jamming, striking, and absorbing losses by the thousand. This is the real plan for U.S. airspace dominance. But there is one fatal vulnerability at the heart of it that adversaries are betting everything on. A single fighter built for $300 million flies faster than Mach 2 and covers nearly 2,000 miles without refueling. This is the next-generation air dominance platform, NGAD, the F-47. It is not just an aircraft, it is a command node. Inside the cockpit, one pilot controls a network in real time. 5 autonomous drones, each with sensors, weapons, and electronic warfare suites, act as coordinated wingmen. The entire system moves as one, linked by encrypted data streams and AI-powered battle management. Every decision the pilot makes radiates out to the entire formation. One pilot, full control. 5 drones respond instantly to threats, jam enemy radars, or launch missiles, all orchestrated by a single human at the center. The design does more than push performance. It changes the math of air warfare. One NGAD replaces a squadron of legacy fighters, directing a digital swarm across a battle space as wide as the Pacific. Digital engineering slashes development time. Prototypes flew in secret years before the public contract. The Air Force office behind NGAD calls it a family of systems, manned and unmanned, each amplifying the other. Digital tools accelerate updates and integration. At this scale, the old model is gone. One jet, one pilot, one kill is no longer the baseline. Now, a single NGAD multiplies force, stretching reach and firepower farther than any fighter in history. But for this system to work, the Air Force needs hundreds of low-cost, expendable wingmen. That is where the economics of the next-generation swarm take over. A single drone built for $5 million costs less than the missile used to shoot it down. The Air Force plans to field over 1,000 collaborative combat aircraft, CCA drones, each designed to flood enemy airspace in numbers never seen before. The math is simple. For the price of one NGAD fighter, the Air Force can buy 60 CCA drones, 4 drones for every manned jet. That 4-to-1 ratio flips the entire calculus of attrition. Instead of risking a $300 million pilot and platform, commanders send swarms of expendable machines. Every drone is a decoy, jammer, or strike asset, sometimes all 3. If an adversary fires a $3 million missile to destroy a $5 million drone, the defender loses the economic battle with every shot. This is not theory. The Pentagon has already awarded contracts to General Atomics and Anduril, pushing rapid prototyping and mass production. The doctrine is clear. Overwhelm enemy defenses. Absorb losses. Press forward. Swarms can probe, confuse, and saturate radar networks, opening gaps for manned systems to exploit. With 1,000 CCA drones in the inventory, the Air Force can afford to lose dozens in a single engagement and keep pressing the attack. The old paradigm, preserve every plane at all costs, is obsolete. Now, mass attrition is a weapon. But if drones can do the fighting, why keep pilots in the loop? That is the question adversaries are already studying. Every drone in the sky answers to one rule. Human judgment cannot be removed from lethal force. That is not a technical choice, it is the law. Department of Defense Directive 3000.09, updated in 2023, requires every autonomous or semi-autonomous weapon system to operate under a layer of operator control. Policy drafters wrote it in clear terms. A commander or operator must authorize each use of force, with rigorous oversight and the power to terminate any engagement. No exceptions for convenience. No shortcuts. Even as AI processes sensor data in fractions of a second, 0.3 seconds to recommend a strike, the human in the loop faces a different reality. Verifying the target, weighing the consequences, and authorizing action can take up to 90 seconds. That delay is built into the system by design. It is a safeguard against accidental escalation, misidentification, or algorithmic error. Operator-supervised modes, audit logs, and activation controls are mandatory. Every engagement must be traceable, reversible, and compliant with the law of armed conflict. This legal framework creates a window, a predictable delay between AI instant calculation and the human final decision. Adversaries know it. They are watching for the moment when that 90-second gap can be exploited. Mach 5 Plus, that is the minimum bar for hypersonic weapons now in rapid development. At that speed, a missile launched from a standoff bomber or fighter covers 1,000 miles in about 12 minutes. The clock starts the moment the weapon leaves the rail. But detection is never instant. Even with space-based infrared sensors and over-the-horizon radar, it can take up to 8 minutes to spot an incoming hypersonic threat. That leaves just 4 minutes, sometimes less, for defenders to track, identify, and respond before impact. Engineers behind the AGM-183 and the Hypersonic Attack Cruise Missile are racing to close that gap. Both programs are funded through the end of the decade, with the first operational deployments targeted between 2025 and 2030. The challenge is not just speed, it is compressing the entire kill chain. Every second shaved off detection or response time is a second gained for survival, but the faster the weapon, the smaller the window for human intervention. In real terms, policy and technology are now locked in a race against physics. When a hypersonic sprint can erase a city in 12 minutes, delay is defeat. The real battle is time. The Pacific map tells the story in numbers. From Guam to the Chinese coast is 1,800 miles. From China to Taiwan, 100 miles. That is the geometry shaping every American and Chinese air power calculation. To project force across that gap, the U.S. fields fighters and drones with standoff ranges close to 2,000 miles. But geography alone does not decide the contest. Production scale does. Open-source inventories show Chengdu factories turning out J-20 stealth fighters at a pace that outstrips U.S. fifth-generation output by nearly 3-to-1. By 2035, analysts expect China to field more than 600 fifth-generation aircraft, each within striking distance of Taiwan and U.S. bases in the region. On the American side, every NGAD system can reach the fight from far outside the threat ring, launching swarms of CCA drones from standoff positions. Range and reach are the U.S. advantage, but the numbers game is relentless. For every NGAD or drone the U.S. deploys, China can answer with mass, more fighters, more sorties, closer to the action. This is about mass as much as distance. The pressure is not just distance, it is scale. Production curves, sortie rates, and inventory counts all bend toward a single question. Can quality, reach, and autonomy overcome sheer numbers? The answer depends on what happens when AI enters the equation. Inside Air Force control rooms, the Advanced Battle Management System fuses sensor feeds from jets, drones, satellites, and ground units into a single combat picture. Data flashes across secure links, AI sorts threats, and the pilot, sometimes 300 miles from the fight, gets a real-time target list. The system compresses the kill chain. What used to take minutes now happens in seconds. I proposes a strike in under a second. The pilot reviews and authorizes in less than 8 seconds. The entire engagement, find, fix, finish, can unfold before an enemy even detects the threat. Program managers call this the 8-second kill chain. By 2026, CCA prototypes will run live sensor fusion trials. By 2030, the first NGAD squadrons will operate with full AI-assisted targeting. By 2035, more than 500 CCAS will be networked into the battle cloud. By 2040, every asset, manned and unmanned, will be integrated, sharing data at machine speed. The timeline is set. The technology is on contract. The only question is whether the clock runs out before the next crisis starts. By 2040, code and doctrine, not just pilots, will dictate the skies. Every breakthrough raises the stakes. The next conflict could be decided in seconds by AI, not aces. Airspace is no longer just territory. It is time. Whoever controls that clock controls the outcome. Share your thoughts below.